Okay, so we're on quantum number 3, and it is called magnetic quantum number. And it gives us the location of the orbital in 3D space. So this looks at the X, Y, Z, or 3D axis. Now, I'm going to be honest with you. You just need to know what this quantum number is. We are not going to apply it because it's very complex, very involved, and very mathematical. If you go on to Honors Chem 2, where you've had a little more math background, then we'll talk about it. But for now, you just need to know that the magnetic quantum number gives you the location of the electron in 3 dimensions. And then your last one is called spin quantum number. Spin quantum number tells the way the electron is moving. And it has a value of either plus 1/2 or minus 1/2. Now, if I have 2 electrons side by side, here's a good question for you. Think this through. If I have 2 electrons side by side, what are they going to do to each other? Push away. They want to repel. 2 electrons side by side want to repel, get away from each other. So would you think they'd be spinning in the same direction or opposite directions? Opposite directions. Good. So this plus 1/2 value is represented by an up arrow, only half of the tip on it. And this minus 1/2 is represented by a downward arrow. When I show this in mapping, these arrows sit on my orbital sublevel, and it would look like this if I had 2 of them. One up, one down. They're spinning in opposite directions. Okay, now we're ready to use the flip side of your card. So turn it over to the empty side. And I'm going to write this, and you want to, is your empty side, does it have lines on it or not? Okay, that's all right. If it doesn't really matter. So you're just going to want to copy this. And then once we get done with it, I'll show you how to use it. Okay, so go ahead and fill that part in on your card. And then up at the top of this, we're going to write order of electron filling. And then I want you to go through and I want you to draw these arrows in. So in the end, your card should look like that. And I'm going to add one more thing in just a minute. Okay, now I'm just going to go through and I'm going to put little numbers on these lines. 1, 2, 3, just in order, 4, 5, 6, 7, 8, 9, 10. So that takes care of all of our orbitals and all of our energy levels. 1 filling down to 10. So here's where we start. This would be where we end if we had a big enough atom. So when I fill, I want to start here, fill everything, watch my finger. I start here, I follow it down. When I get to the end, I jump up to the next number, follow it down, get to the end, jump up, down to the end, jump up. So it's always move to the end, jump up to the next. It's not like this, because that in the end would get you messed up. You always have to jump from top to top. Follow it down, go to the top. That's right, follow, down, and jump to top for electron fill. And that'll make sense in a little bit, I hope. Okay, can I move this, or anybody still using it? We're good? All right, so we're going to look at mapping electron location using quantum mechanical model. And there are 3 rules we must follow. The first one is called Hund's rule. And it says the electron will fill the lowest energy level first. So if I only have 1 electron, it's not going to fill energy level 5 first. It's going to start in energy level 1. That seems to make sense. The second one is called the Aufbau principle. Of course, these are named for the individuals who came up with them. The Aufbau principle says each sublevel within an orbital gets 1 electron before any get 2, often referred to as the sharing rule. It's like when you were a little kid and your mom gave you a package of Skittles and you had to share with your brother or sister. You do that. 1 for you, 1 for me, 1 for you, 1 for me kind of thing. That's what the Aufbau principle is. Everybody gets 1 before anybody gets 2. And then the last one is called the Pauli exclusion principle. And I'm going to give this to you now. We'll talk more about what it means later. It says that no 2 electrons can have the same set of 4 quantum numbers. So no 2 electrons can have the same set of 4 quantum numbers. because that means they would be in the exact same location. And we know two electrons can't be in the same space at the same time. They repel each other. It wouldn't happen. And this will make more sense once you start mapping them out. Yes, ma'am?
Is that just for like one atom versus it isn't?
Correct. If I'm talking about gold, I can't have two electrons in gold that are exactly at the same place at the same time.
Okay.
That doesn't mean gold and silver couldn't have an electron in the same energy level, same sublevel. It's only when we're talking about one atom. So let's look at how we use this, because it's just a lot of blah, blah, blah stuff until you figure out how to use it. So let's look at an example. Go ahead and get your periodic table out too. And I'm going to start small and we'll work bigger. I'll start with things you should know. Let's start with beryllium. Keep your little card out too, because you're going to want that. Let's see, where did I put that? Keep your card and flip to this side. How many electrons does beryllium have? 4. What's the atomic number of beryllium? 4. So if I pick 1 through 20, you should know it. You should be able to tell me how many electrons. So beryllium is atomic number 4, which means there are 4 electrons. So the first thing we're going to do is called electron configuration notation. From now on it will be ECN. This is the big one. This is the one where you show everything. So I'm going to write my 4 electrons right here, because you've got to keep track of them. Now when I look at this, what is the first place that would fill electrons? Can you tell me? 1 what? Okay, so I'm going to write that down. 1s. Then my next question would be, how many sublevels are within the S? And you might have to flip back in your notes and find it. How many sublevels? 1. Good. There's 1 sublevel, which I show like this. How many electrons can each sublevel hold? Piece. 2. Yes. So 2 electrons. Do I have 2 electrons? I say to myself, why, yes, I do. I have 4. So I'm going to go minus 2, which gives me 2 electrons left over. And I'm going to come down here and I'm going to fill in my electrons. How do I show them? I show them with the arrows. 1 goes up, 1 goes down. They would be in opposite spin. Okay, so I've used my 1s. I follow it to the bottom. Where do I go next? I hop up. What fills next, Summer? The 2s. It is of the same, it's going to go along the same lines. 2s. All the s's will stay together. It's an S, so how many sublevels does it have? 1. Good. 1, and that 1 sublevel, Trevor, can hold how many electrons? 2. So I'm going to, do I have 2? I say to myself, yes, I do. I'm going to put them in, and I have to take them away. Oh, yay, there's the point you want to get to. I have no electrons left, so I'm done. I have just mapped my electron location for beryllium. This would be electron configuration notation. Yes, sir.
So if it's like, let's say one with 5 electrons, would it, do they always like, the air does
Well, let's just do that one. Yes, always goes up first. They all spin the same way first and then the opposite way. Yes, ma'am.
So for elements with like a lot of electrons, does the line just keep on getting longer?
Yes, we're going to do a big one before you leave here today. Okay, so that's a little tiny one. let's do something a little bigger. Let's look at something else you should know. Let's look at calcium. How many electrons does calcium have? 20. Atomic number 20 equals 20 electrons. Now I'm going to suggest that you leave yourself some room and you move down on your paper. And starting tomorrow, I'll have paper for you. So let's start with calcium. What's the first thing that fills, Kinsey? 1s. So I'm going to draw 1s. And then I'm going to go ahead and put in my electrons. 1 up, 1 down. I'm going to come up here and go -2, which gives me 18 electrons left. What fills next, Hunter? 2s. 2s, Emma, can hold how many electrons? 2. Reagan, do I have 2 left? Yeah. So I'm going to subtract another 2, which will leave me 16 electrons, and I'm going to fill them in. Okay, now, according to your card and the order of filling, Natalie, what fills next? 2p is right. Now look at this, because this is important. 2p is a little farther away from the nucleus than 2s. So I'm going to move over and up just a little. I'm going to write 2p. See, I'm in the same row, but I'm up just a little. How many sublevels does p have, Bryce? He doesn't remember. Elijah? Trevor? 3. So I'm going to draw 3 lines, which, Nolan, means how many electrons can that hold? What? Oh, sorry. Elijah? Redeem yourself. 6 is correct, because each one can hold 2. So I look up here and go, do I have 6? Yes, I do. I'm going to subtract 6, which leaves me with 10 electrons. And then I'm going to come down and put them in. Watch what I do here. Everybody gets 1 going up before anybody gets 1 going down. And now I can come back and put my other 3 in. Okay, then I go to my card. Evan, what fills next?
3s.
3s. So I'm going to come up just a little because now I'm in the 3rd energy level. We know it has 1 orbital, which can hold 2 electrons, and I have them. Now I'm down to 8 electrons. This part up here is really important. People mess this up all the time, which then messes up their answer. I'm going to put my 2 electrons in, and then I have to see, where do I go next? Who have I not heard from today? Reagan, I don't know if I've heard from you. Where do I go next? 3p. Cooper, how many does p have? How many sublevels? 3. So I'm going to draw my 3, which would be 6 electrons. So -6, which leaves me with 2 electrons. So then I'm going to go ahead and fill them in. 1, 2, 3, 4, 5, 6. Am I done? No, I'm not done yet. What do I have left? I have 2 electrons left. I have to put them somewhere. What comes next? Matthew? 4s. Good. So I'm going to go up here, make it just a little bit above my p, and I have 2 electrons it can hold 2. So I'm down to 0 electrons. Now here's where you want to stop, and I should have 20 electrons. That's what I started with. So count and see, do we have 20? Am I good? Yes. So this is my electron configuration notation. I'm going to show you the next thing. We're going to look at orbital shorthand notation, OSN, which is quite easy. One rule, keep energy levels together. And work S to F. And that'll make sense when we do a bigger one. So keep your energy levels together and work S to F. So I'm going to grab myself some kind of a highlighter if I have one. Yeah, here's one. Okay, so this is what it looks like. I show my energy level. I start with the lowest. I show my energy level. I show my orbital. I look at how many electrons I have. There are 2, correct? The number of electrons becomes a superscript, like an exponent. So I write 1s2. Then I'm going to put like a little blob by that so I know I used it. I don't want to scratch it out yet. 1s2, the next thing that filled, and you can use your card when you do this, was 2s. Is there any more 1s? There's not any more 1s, so I'm okay to go to my 2s. So I would write 2s. What's my exponent going to be, Summer? How many electrons do I have in 2s? Just 2, so it's 2s2. Okay, so here's my next question for you. See if you can answer this. Do I go to 2p or do I go to 3s? What would come first? What do you think? 2p. Why'd you pick that? Because I have to keep my energy levels together. So I'm going to write 2p, and my exponent in that one will be what, Kins? How many electrons do I have? How many electrons do I have? 6. Good. So 2p, 6. I understand why you said 3. Now I'm going to put a little dot by that because I used it. All right. What comes next, Trevor? 3s, how many? 2. Good. Does this make sense, people? What would come next? Nolan? 3p what? 6. And then all I have left is 4s2. That is orbital shorthand notation. Now, the next thing I'm going to show you, and you have to get your periodic table out for this. Can I move this? Are we good? And we'll do another one so you can see if you can do it. Is called noble gas notation. So I'm going to show you. What are we doing here? This was calcium, right? Just move my finger. So calcium is right here. Find calcium and put your finger on it. Now move up a row. So directly above calcium is magnesium. So I move up to magnesium and go all the way to the end of the row. What noble gas is above it? Argon, yes. Do you see how I got that? Up and over. If I were on niobium, I would go up and over, and I'd be on krypton. So I'm on calcium, I go up, and I slide all the way to the end, which gives me argon. So I'm going to take argon and put it in a bracket. And put my noble gas in bracket. That means, whoops, calcium has the same configuration to this point as argon. Plus, and I'm going to show you how to figure out the plus. So argon has how many electrons, people? 18. So here's what I'm going to do. I'm going to follow my order of filling, and I'm going to get rid of 18 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. Did you follow that? Yes, and if in doubt, you'll have your card. You just figure out what's the path. This is what's left. So I put 4s2 outside of it, plus, I'm going to say plus what is left. So if you were to ask, what element is this? and I give you one and we didn't do it together, you would go to your periodic table and you'd find argon and go, okay, argon has 18 electrons plus 2 more, 20 electrons total. It equals calcium. Now look at that and see if it makes sense and ask questions if it doesn't. We're going to do another one. I know it's a lot at once. Are we good? Do you feel like you sort of got it as we went through it? Okay, so let's look at, let me pick something different. Oh, let's look at strontium. Go to your periodic table. Tell me how many electrons strontium has. 38. It's even bigger, which means it's going to take a little more space. So let's work through it again together. So you've got one more that we did together. So I'm going to start, where do I start? What always comes first? 1s, and I have 2 electrons, and I know I have 2, so I'm going to put them in. One s is followed by 2s. So I'm going to put my 2s in. Now I'm down to 34 electrons. What comes next, Kinsey? 2p, which has 3 sublevels, which means it can hold 6 electrons. So I'll put my 6 electrons in. That puts me down to 28 electrons. After 2p, what do I fill, Elijah? 3s. Can hold 2 electrons. So I subtract 2, 26. After 3s, Hunter, what's next? 3p. 3 sublevels, 6 electrons. So let's put them in. Okay, after 3p, what fills, Natalie? 4s, good. 1, 2. Ah, here's something new. After 4s, what happens, Matthew? 3D. This is a place where they start overlapping. So I'm going to come up where my 3 is. I got to go up, and I got to go over and put my 3D in. Ah, how many orbitals does D have? 5. Good. 1, 2, 3, 4, 5. So it can hold how many electrons? 10. So I have to subtract 10, which leaves me 10 electrons. So let's put them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
It's 18 electrons. Sorry.
Pardon me?
You have 8 electrons left. You missed you didn't count.
Oh, is that 28?
It's supposed to be 18.
2, 4, 6, 8, 10.
No, after the 4s, it should be 18, because that's when we pass 20 for the calcium.
20 should be right here.
You didn't count 4s up there.
I didn't, so, okay, so you're telling me I needed 20. I understand. 20 minus 2 should be 18. Is that what you're telling me? Thank you very much. You got to watch that. See, I just made a mess up that a lot of people do on their test. So I only have 8 electrons left. Now am I with you? Yes. Okay, so 3D, after 3D comes what? Reagan? 4p, so I'm going to put 4p up here in my p row, but it has to be a little above that. Has 3 sublevels. Do I have 6 electrons left? Yep, so I'm going to put them in. Now I'm actually going to subtract them, which leaves me 2 electrons. And after 4p comes, Cooper, what comes next? 5s, good. 2 electrons, and I have 2 left. And you go, thank you, Lord, I'm finally done. Now, you do or orbital notation shorthand, or orbital shorthand notation. And then we'll compare them. What's the one thing you have to be sure you do? What do you have to keep together? Energy levels, don't forget. Yeah, you keep all those together because they're the same energy level. Even though they don't feel that way, you still keep them together. When you've got it, stand up.
Good morning, everyone. Please stand for the pledge.
We'll finish in just a sec.
I pledge allegiance to the flag of the United States of America,
to the republic
for which it stands, one nation under God, indivisible, with liberty and justice for all. Attention seniors, the picture professional photo in for the yearbook. Vertical format and JPEG preferably. Send them to Livia Thomas at mymeans.k12.oh.us or Mrs. Schroep, c.schroep@mymeans.k12.oh.us.
You can check with me.
You can also scan a physical photo into the
Then do your noble gas.
If you don't get a picture in, the one taken by light touch will be used. Deadline is March 30th. Attention seniors, our next Reading a Buddy event will be next Monday, February 9th at 8 a.m. If you're a late arrival senior and can come in early next Monday, the kindergartners would greatly appreciate it. Attention artists, if you're interested in helping paint faces during Biking Fest, please see or email Mrs. Poppleman. Be meeting tomorrow in Electron during meeting period for any girl planning to play softball this year. Evan Ondera, Abigail Witten, Savannah Kaiser, Jack Haymaker, please see Mr. Rutledge. Following today's meeting, FCCLA member completing in star events, please report to Mrs. Moran's room at this time. Thanks, and have a great rest of your Monday and Groundhog Day. Bye.
Okay, so did this make sense to you? Did you get it? Any questions? All right, I want you to do noble gas really quick. And then I'm going to give you what your homework is. So try the noble gas notation. Everybody remember how to do that? Up and over. Okay, and we'll do one of those tomorrow. Right, we'll do one tomorrow so you see what it is. When you've got it, stand up. Ooh, that was a pretty easy one. Is that right? Yes? Makes sense? Okay, I'm going to give you two I want you to do for homework. Bromine, and let's do vanadium. All configurations. So, do electron configuration notation, orbital shorthand notation, and noble gas notation on a sheet of paper, and then you're going to turn it in tomorrow and you'll get a grade for it. Okay? Questions? Does it sort of make sense? All right, we'll do more with it tomorrow. Yes, I hear you knocking.